10 seconds. Not 10 seconds. Thing fell down. My phone fell down. Got restarted. Still September 13th.
Directly decode attempted words from brain signals to speech. And in 2026, not only are we going to triple the number of the electrodes from 1,000 to 3,000 for more capabilities, we're planning to have our first blindside participant to enable navigation. And in 2027, we're going to continue increasing channel counts, probably another triple, so 10,000 channels, and also enable, for the first time, multiple implants, so not just one.
You know, there's a woman who's on TikTok. She just built a, hold on, something.
And finally, in 2028, our goal is to get to more than 25,000 channels per implant, have multiple of these, have ability to access any part of the brain for psychiatric conditions, pain, dysregulation, and also
that might be actually kind of cool, but you basically need a way for nanobots. You need nanobots basically, because you need to spread out into the brain with like a web of,
And all this is to say that we're really building.
You'll never be able to do it without just the chip.
Technology that would allow us to have hundreds of thousands, if not millions, of channels with multiple implants for whole brain interfaces that could actually solve not just these debilitating neurological conditions, but be able to go beyond the limits of our biology. And this vertical integration and the talented team that we have at Neuralink
surgery
has been and will continue.
Basically, the Borg. You have to make the Borg. Basically, we are the Borg. And
just to recap real quick, Neuralink is implanted with precision surgical robot. It's physically invisible. And 1 week later, users are able to see their thoughts transform into actions. And to share more about what that experience is like, I'd like to welcome Sahej to the stage.
Oh, yeah.
What's up, guys?
Two-dimensional interface for a three-dimensional object.
That's interface team here at Neuralink. And I'm going to be talking about two things.
Yeah, I can see some issues with this.
The first thing is, what exactly is the Neuralink device capable of doing right now? And the second one is, how does that actually impact the day-to-day lives of our users?
And technology is
very simply put, what the Neuralink device does right now is it allows you to control devices simply just by thinking. Now, to put that a bit more concretely, I'm about to play a video of our first user. His name is Nolan, if you remember from DJ Section. And what Nolan is doing is he's looking at a normal off-the-shelf MacBook Pro, and with his Neuralink device, as you're going to see, he's going to be able to control the cursor simply with his mind, no eye tracking, no other sensors. And what's special about this particular moment is this is the first time someone is using a Neuralink device to fully control their cursor. This is not your ordinary brain-controlled cursor. This is actually a record-breaking control, literally on day one. Decades of brain-computer research.
We got an issue. This is not going to work. This entire company is not going to work. Now, according to you have to make people take immunosuppressants. This is not going to work. Like, literally, none of this shit is going to work at all, ever.
Oh, well done, man. Well done.
He's a new record holder.
Anyway, yeah.
I thought it was higher. I thought I would have to get to 5 or something. Oh my gosh, that's crazy.
Yeah, okay, Elon, I'm so sorry that I spent like 5 minutes to Google and realized all these people's life's work is completely useless. I'm so sorry. You can't do that. There's no way. The human brain will not allow you to put an implant like this without. So basically, these people are wasting their lives for absolutely no reason. So sorry. Oopsie daisy.
And here we actually have.
Well, I mean, it's worth a try.
Now, what's special about this particular clip is Nolan is not
Anyway, unless you figure out how to
It's cool, you know, you're using one joystick and then you're clicking like a couple.
hard
buttons
object
for
will not
items.
work.
What
Your
would be
brain
even
cells
cooler
will
is what if you
form
could
a scar, causing
control two joysticks at
inflammation,
once,
and eventually it will
simultaneously with
cause
your
cancer.
mind.
So
What I'm about to show you,
brain
I
cancer.
think this is for the first time someone
That's,
playing a first-person shooter game with a brain.
that's not
computer
gonna work,
interface.
Elon. You're gonna have to do
This
the
is
other that girl was a
RJ
TikTok. She
playing
make
Call
the
of
outside
Duty,
implant over your brain.
controlling one joystick to move and,
And,
then the other joystick to like think.
It's basically a tiara. She was wearing like a tiara that's
Here's Alex
so
shooting another person.
Oh dear God.
too slow. Yeah.
I don't know, dude. I want him to freaking shoot you won't when I do. I know it is shot in the face.
Yeah. Precision control of
Now we have a
precision
visual
control.
sense
You
of
know
what
that
the
thing.
can do.
She did it with
Very
a crown.
question is,
I have one of those. I have a meditation device that measures my brainwaves. You know, and she basically jury rigged the meditation device and the controller, and she did the exact same thing. It was just something you wear on the outside of your brain.
Randomly during
So,
the day, how he
the
enjoys
thing that she
using
was wearing
VCR
outside of
a couple months
your
ago.
your brain
This is
now.
candid reaction.
Your brain has waves that go out to after
Basically
editing.
all
So
day from when I
this is not gonna
wake
work,
up,
but
I
it's
try to
okay.
wake up at like 6 or 7 a.m. and I'll do work until session. I'll do session, and then I'll
That's
work
really cool,
until, you know, 11, 12 p.m. or 12 a.m.
Wow.
I'm doing like I'm learning my languages. I'm learning my math. I'm like relearning all of my math. I am writing. I am doing a class that I signed up for, and I wanted to point out that like this is not something
Neurotoxicity,
I would be
degradation,
able
and
to
death of
do
nearby neurons.
out like without the nerve.
Next, I want to talk a bit about Brad.
This is
because
actually
we
part
already
of the
has
mechanism
ALS
for
cyber,
COVID.
And
So
Brad also has ALS, and what separates him from other users is he's actually nonverbal, so he can't speak. Why this
interesting.
is pretty relevant is he relies, at least before the Neuralink, on an eye gaze machine to communicate.
Yeah,
And
that's so
a
cool.
lot of eye gaze machines you can't use outdoors. You really need like a dark room. So what this means is for the last 6 years since Brad's been diagnosed with ALS, he's really unable to leave his house. Now with the Neuralink device, we're going to show you a clip of him with his kids at the park, shot by Ashley Vance and the team.
It's cool. No, that's so cool.
I'm absolutely doing more with Neuralink than I was doing with eye gaze. I've been a Batman for a long time, but I go outside now.
It's so
Going
cool.
outside has been a huge blessing for me. And I can control the computer with telepathy.
Dad's watching. Look, he's watching on the camera.
The last user I want to talk about is Alex.
Cool.
We've seen some clips of him earlier. What's special about Alex to me is he's a fellow left-handed guy who writes in cursive all the time. And what he mentioned is since his spinal cord injury from like 3-4 years ago, he's been unable to just like draw or write. And he always
Foreign
brags
body
about how good his
reaction.
handwriting was. So we actually got to put it to the test. We gave him a
How
robotic
did
arm.
Neuralink
And I think this is the first time he tried using the robotic arm to write
solve
anything.
the
And this is
immune
a
response?
version of writing at the convoy trial and drawing something.
How did neurons solve the immune response to four objects?
Now, yeah, controlling a robotic arm is cool, but this one has a clamp. And what would be cooler is if you
Yeah,
could
it
determine the
indicates
actual
immune
fingers,
response to
the
this
actual wrist,
challenge.
all the
Unless
muscles of the
you
hand
suppress
in
somebody's
real time.
inflammation,
Just
this
in the
is
past
never
couple
going to work.
weeks,
I mean,
we were able to do that with Alex, and you're about to see him and his uncle.
glial
uh,
encapsulation. When immune cells microscope create a scar around the implant, blocking nerve signals. So
Rock, paper, scissors, shoot. Rock, paper, scissors, shoot.
really,
Rock,
threads.
paper, scissors, shoot. Scissors. Bullshit. Thumb war?
There we go. May 2024. It didn't work. It did not work.
Cool. Controlling
May
yeah,
2024.
that's
You
really
already know. I mean, there's no way to solve the human immune system. So you can't do this. It's basically not possible to do.
Controlling a robotic hand on screen is obviously not super helpful for most people. Fortunately, we have connections with Tesla, who have the Optimus hand, and we're actually actively working on giving Alex an Optimus hand so that he could actually control it in his real life. And here's
what was that woman, the TikTok woman? Let me see the woman's name.
Alex's neural signals on an Optimus hand. Sean, if you want to play that. Yeah.
Playing video games in mind. There we go. Streamer. There we go. I got great big story. It's 1 year ago.
Actually, let me maybe add
Harry
a few things to that,
virtual.
which is so.
Yeah, it's so cool.
As
What's
we
her name?
advance the Neuralink devices.
Perry
to actually have full body
that is so cool.
control and sensors from an Optimus robot. So you could basically inhabit.
TikTok.
An
this is
Optimus
TikTok.
robot. So
That's
not just
why.
the hand.
I've logged in.
The whole thing.
What's her name?
So you could like
Perry,
basically mentally remote into
we're talking to Elon Musk, by the way.
robot and be kind of cool. The future's gonna be weird.
Yeah, she's using her brain. I mean, this one was.
Pretty cool.
This is much better.
And then,
It's much better. She created a brain. A helmet basically. And,
Gaming is exactly as it sounds.
Perry Correa, I guess. Never psychology.
we think in the future we'll be able to.
Yeah, it's just an EEG. Pick up.
An Optimus arm or legs, and so you kind of remember that scene from
Same thing.
Star Wars where Luke Skywalker gets
Your
his
brain will
hand,
actually
you
do
know,
it, but no immune
lightsaber,
response, and
he gets kind of a robot hand.
there's basically no way to.
I think
So
that's
the human
the
brain
kind of thing
does will
that,
not allow you to do
we're
what
gonna
it is
do
you're
in the
doing.
future,
Nice try though.
With Neuralink and Tesla.
There's just no way.
So it goes
Scientifically,
beyond
there's
just
no way.
operating a
So
robot
it's not
hand,
possible to
replacing
do,
humans
but-
and having kind of a whole body robot experience. And then I think another
So,
thing.
it's a good thing. It means we are not in a neural simulation in the Matrix. What the Matrix saying is not possible to do.
Where the damaged neurons are, so you can take the
Well, you do.
signals
You have
from the
proven.
brain
You have
and-
proven
and
something,
transfer
Elon.
them
We are
from
not in the Matrix.
past where the neurons
The
are
human brain will
damaged
never
to
allow you to
to
stick
rest
a,
the
you know,
body
that
so
thing
you
with the
can,
Matrix thing into your
reanimate the body
brain
so
and
that
then not create
have
an
a
immune
Neuralink
response.
implant
Again,
in the brain
maybe
and
a few
one
years
on
back
your
between the
spinal
brain
cord, then
denies the
you can actually bridge the signals
so
and
we are
you can
definitely
work again
100% not in the Matrix.
and have
I mean, I
full
can say
body functionality. Obviously, that's what people would prefer. To be clear,
we are definitely not
That would be
100% not in the
preferred
Matrix. It's not
outcome.
possible to do.
And
This thing is not possible
And
to
so that
do
even if
because
you're-
I'm not, you would have to suppress the entire human immune system
we
basically.
believe, I'm actually
Including the microglia and the astrocytes. And astrocytes do not just function as immune cells; they function as neuron in position. So if you suppress astrocytes, you basically turn everybody into a
Yes,
retard.
hello everyone.
I mean, you will never be able to. I mean,
application group.
yeah, because if you suppress astrocytes, you don't just suppress the immune system; you suppress brain neuron connections from birth, which means babies will basically become retards from the so. Scientifically speaking, the way the human brain works, we are definitely not 100% not in the Matrix. That's what you prove. So, plus what you're gonna do at the end of this, I mean, it's still worth it. I mean, basically, scientific proven the Matrix does not exist. So,
It's really cool because you can build a new feature, you can build a new machine learning model, a new software feature, and test it on the same day with the participant and get
Yeah.
feedback.
that's an interesting question though. But the quantum entanglement part of this thing is actually true,
Address
which is
very diverse needs
absolutely
of the
true.
different users that we have, from moving a cursor to
Yeah,
playing
hi.
games,
Right.
to moving
My name's
a
Andrew, by the way.
multiple fingers.
1 year ago.
And we could not have done it without the Neuralink device. The Neuralink device gives us something that no other device can give us, which is a single neuron recording from thousands of channels simultaneously.
Yeah.
The telepathy product is basically recording the neural
Hey, you actually
activity
hit
from
something,
the small
right?
area in the motor cortex that
Yeah, is
involve
that
in execution of
wow.
hand and arm movements.
Wow.
But if we go only about 2 or 3 inches below, there's another brain area that's involved in execution of speech. And with the same device, with the same machine learning model architecture, the same software pipeline,
It's so cool.
the same surgical robot, we can have a new application. And we can do it very quickly. It's really interesting that if we can
Yeah, because you don't have to.
someone intention to speak
I know.
silently and non-vocal communication, we can use that to revolutionize the way we interact with computers, with technology, and with information.
Okay, what she's changing is basically how I kind of learn how to control hurricanes. Like for me, because I'm telepathic and telekinetic, I basically learned how to
much faster,
press buttons of the universe, basically.
The computers will understand what you want to do. And
Yeah, because that's what I did. And I did not know I was
you can now have an
telekinetic.
interface with
either-
AI that you will be able to retrieve information, will be able to store our thoughts anywhere.
I mean, this woman is basically saying she had an electrode over her brain,
because we
and
build a fundamental technology, a platform, and we build
sorry.
everything in-house.
when you figure out when your mind is connected to the universe, you basically have to learn how to press the buttons
Now
still.
I'll
So
pass it to
I never
Luis
really learned how to
talk
press the
about
buttons.
why for this app.
Press the buttons for the universe. I don't know how to press the buttons because I couldn't save Charlie Kirk's life, so I couldn't control the universe with my mind well enough to save Charlie's life, which is
starts with,
the problem.
of course, unboxing.
Push
The
the
very
key.
first time that a participant
Yeah.
pairs to and meets their implant, this invisible part of their body,
I know you just sort of visualize it, right?
materialize across the display. From there, they'll go into body mapping and actually imagine moving their arm again and get
Yeah.
a feel for what feels natural to them and what doesn't. And we'll take that into calibration,
That's so cool.
using one of those motions to actually move a cursor again.
Yeah.
Iteratively refining their control as they go throughout this process
Yeah.
until finally they're teleported back to their desktop and can experience the magic.
That's what meditation
neural
is.
control
They try
for the
to
very first
learn
time.
how to press
And our
Andrew as
control
like a button.
interfaces,
The people who learn meditation, that's what they
the
did.
OS integration that we do really shines.
Try to operate
Letting us
Andrew as a
adapt
machine.
both, control and feedback for every interaction.
Yeah.
So for familiar interactions like
You need a more
scrolling,
comfortable,
we can surface an indicator of the
comfortable.
scrollable parts of the display. Add a touch of gravity to automatically pop a participant's cursor onto that indicator as they approach.
Yeah.
Show the actual velocities that we decode inside of it, and add a bit of momentum to those velocities to carry them forward as they glide across the
That
page.
is so cool.
There are also unique interactions that we need to solve for in this space.
Yeah.
For example, when a participant is watching a movie or just talking to somebody next to them, the brain is very active still, and that activity can actually induce motion in the cursor, distracting them from that moment. So when a participant wants to just get their cursor...
Alexis was saying that it should be easy, and she said theoretically she says everything she could get everything she wants, and by being connected to
they can push it out
the
with
to
either
the time
a
machine,
push,
so.
or in this case, a gesture. And of course, it goes without saying,
that's
all
interesting.
of these control interfaces are
Can't headshot it.
hand in hand with the
Difficult to
participant.
headshot.
So huge
Yeah,
shout out to
headshot it.
Roland and Brad for helping
Never
us
mind.
design these two.
I just because that's
Control
the
interfaces, of course, extend typing. We have a great
Oh my God, did I just
keyboard that does
help you
everything
headshot
you'd
somebody?
expect it to, popping up.
Holy
with
fuck,
our
shit.
Clicks on a text field.
Let's see if we can do this together.
On the surface of the key, and supporting both dictation and swipe.
Dude, it must be a lucky shot. I mean, headshots. I mean,
Hi everyone.
I mean,
an ML engineer here at Neuralink, and I must say,
I mean, where's the line? Dude, you know, I think I should. It must be a lucky shot, but
when you think of the inputs
a lucky
to
shot
most
together.
ML systems out there, you might think of pixels, of tokens, or of a user's Netflix watch history.
lucky shot.
The input to our systems is a little different.
Freaking lucky.
It is pure,
Freaking lucky
raw
shot.
brain power. And when we think about the ML systems we can build here at Neuralink, really we're limited by our imagination and our creativity. There's no reason our ML systems can't do anything that the human brain can do, such as controlling a phone,
Yeah, I know,
typing, or even gaming.
I know.
Right here to my left is actual footage of Alex, one of our
her name?
participants, playing a first-person
Harry
shooter
Carroll.
against RJ, another one of our participants. Now, for those unfamiliar with first-person shooters, this is not a trivial feat. It requires 2 fully independent joysticks, or 4 continuous degrees of control, as well as multiple reliable buttons. Now, contrary to popular belief, the Neuralink does not simply read people's minds. It's simply reading neuronal activations corresponding to motor intent. So one of the fun challenges
That's
of
too
this
low.
project was figuring out which motions were going to be mapped to the joystick.
Somehow, because
We started with the typical
it's brain
left
waves,
thumb
so-
and right thumb, but quickly found that the dominant hand overshadowed the non-dominant hand.
it's a misunderstanding of consciousness and
We had
how
one of our
consciousness is
participants
made.
imagine walking for the left joystick and
Because you're
for the right
measuring,
joystick.
you're measuring neuron firings.
Naturalistic motions.
That girl's trying to
Like you
measure
might do
brain
virtual
waves,
reality in
entire
real
brain
life.
waves,
And that was
and
really cool to watch.
that's why her
What
precision
we
control is
ended up
better.
on was the
This
thumb
is
for
the wrong
left
way to do
joystick
things.
and the wrist for the right joystick.
Entire waves
And
of
I challenged the audience to try to replicate their motions. I'm really in awe.
Because Neuralink measures neurons, her device measures waves, the actual brain waves themselves.
To my
That's why
left
her
here,
control's
you can
better.
see RJ completing his first ever cursor calibration with a redesigned open loop flow where he first gathered information about his intent and how to map the neural activity, to the first time he controls a cursor, to the final product where he has smooth and fluid control of his computer.
Oh,
And most remarkably, this experience took only 15 minutes from start to finish. 15 minutes.
Because you're basically forcing your brain to fire maybe 25 neurons and 20 connections to fire,
15
or
minutes
20,
from no control
25
to
connections,
fluid
whatever.
computer use.
The brain doesn't work like that.
Contrast that to a year and a half ago with P1, where that was multiple hours to get to the same level of control and several engineers standing around a table pulling their hair out. There was virtually no need for Neuralink engineers to even be at this session. This was basically an out-of-the-box experience for our participants.
It's easier to fire like a million neurons than
And
to
even
fire
more
just a few
remarkably, we're
for the
continuing
human
to
brain.
smash day
That's the
one
problem.
records, with RJ being able to
Because that
achieve
woman figured out that you
7
can,
BPS
she's controlling
on
a
the
single
very first day
button
of
with
the
maybe
Neuralink.
like a billion neurons. You're trying to control like maybe one
Now,
button
such
with
an
maybe
effective and efficient
a
calibration process
few hundred
is only
neurons
made
connected to a
possible
few.
by high-fidelity estimations of
That will
user
not work.
intention,
So
or labels.
it's easier to.
And
I
to
mean,
briefly illustrate just how challenging of a problem that is, this is an animation of myself trying to draw
Mm-hmm.
circles on my desktop with a mouse. Now, the task was simple. Draw uniform circles at a constant speed
with
repeatedly.
your hand.
And as you can see by that animation, I am horrible at that.
No,
Even
no,
though
no,
my intent
yeah.
was pretty obvious, unambiguous, the execution was really poor. There is a ton of variation in both speed and the shape itself. To visualize this a little differently, each row here is one of those circles unwound in time, with synchronized starts. And you can just see how much variation there is in the timing of each circle, as well as
Just drawing
what I'm doing
circles
at
pretty
any
hard
given
yeah,
point in time.
with your hand, yeah. Drawing as soon as that goes.
Orthogonal to the labeling problem is neural non-stationarity, or the tendency of neural signals to drift over time. And I think that's honestly a beautiful thing, right? If your neural signals didn't drift, you couldn't grow. When you wake up the next day, you're not the same person you were the day before.
Yeah, but try
You've
drawing a
grown, you've
perfect
grown,
circle
you've
with that
changed.
device
And
she
so
has,
too
though.
must
I'll
your
bet
neural
you can
data
do it.
change. This
And that's what the
animation here is
meditation
a
is trying to
simple
teach.
illustration of the learned representation by the decoder and how it drifts the further away we get from the day it was trained on. This is one of the key challenges we need to solve here at Neuralink to unlock fluid and product level experience for our users.
Yeah, it's interesting. Now I know why people meditate. you know what they're doing when they're
Hey everyone, my name
meditating.
is Joey.
Anyways.
Blindsight
Try to
is our
control
project to
Andrew
build
with
a visual
fucking
prosthesis to help
retarded,
blind
crazy
see
people.
again.
Anyway.
Users would wear a pair of glasses with an embedded camera and receive an implant in their visual cortex. Scenes from the environment are recorded by the camera and processed into patterns of stimulation delivered to the brain, causing visual perception and
Cardio.
restoring functionality.
Very
Now,
cardio.
Blindsight will be enabled by placing our implant into visual cortex. This is a new brain area
You're
for us,
following-
and this
I am
brings
following
new
her already.
opportunities and challenges. So, the surface of the brain for visual cortex represents just a few degrees of angle in the center of the visual field. Larger fields of view are represented deep within the cortical folds
Here's
of the
TV.
alkaline fissure. Our threads are able to access these deeper structures, providing the possibility of restoring vision over a functionally useful visual
EEG
field.
tech into game control.
So the N1 implant has had experimental stimulation capabilities for quite some time, but our new S2 chip is designed from the ground up for stimulation.
I think
It
that might be
provides
EEG.
over 1,600 channels of electrical stimulation, high dynamic range recording capabilities, and a wide range of microstimulation.
What did she build the EEG or something?
We can achieve these capabilities because we're vertically integrated And
She
we
literally
designed
built
this
that thing. I
customization
mean, what the
in-house. Similarly, we
Can't believe she
designed
literally built that
fabricated
thing
electric
herself.
threads in-house.
That's
And
amazing.
here you can see one of our standard threads designed for recording in an electron micrograph. For blind sight, our requirements are a little different, and our vertical integration allows us to rapidly iterate on the design and manufacturing of these threads for this new purpose. So here, I'm using red arrows to highlight the electrode contacts, which are optimized for stimulation. And as you can see, they're a little bit larger, which results in a lower electrical impedance for safe and effective charge delivery, which is important for blind sight. Now, how can we calibrate our implant for blind sight? So here's one way.
Interesting.
We stimulate on the array, picking, say, 3 different channels. The user perceives something, say 3 spots of light, somewhere in their visual field, and points at them. We track their arm and eye movements and repeat this process for each of the channels on the array. And here's what a simulated example of a blind sight vision could look like after calibration.
It's interesting.
Now, I showed you how for blind sight we need to insert threads deeper into the brain than we have previously. And doing this requires state-of-the-art medical imaging. So, we worked with Siemens to get some of the best scanners on Earth. We built out our imaging core from scratch in the past year. Actually, it was faster than that. It was about 4 months from dirt to done.
Well, this could be done
We scanned over
biologically.
50 internal participants, building out a database of human structural and functional anatomy. What can we do with the imaging information from these scanners? So medical imaging can be used for surgical placement. It lets us parcelate out brain regions by their function. And we use our imaging capabilities to refine the placement for telepathy. It also gives us the capability to target new brain regions for future products, such as blind sight or speech prosthesis. And we're working towards more capabilities. So one-click automated planning of surgery from functional images to robot insertion targets. Here you can see a screen capture from one of our in-house tooling to do end-to-end surgical planning. You can see a region of motor cortex known as hand knob and the thread trajectory planes that will be sent directly to the robot. This is a really incredible degree of automation that's only possible because we're controlling the system from one end to the other.
The actual waves themselves.
My name's John, and I lead the robot mechanical team. This is our current R1 robot. It was used to...
What is a brainwave? What is a thought? You know?
This robot works really well, but it has a few flaws. One of which is the cycle time is rather slow. So to insert each thread, it takes, in a best case scenario, 17 seconds. And in many cases, external disturbances cause us to have to retry to grasp that thread and then reinsert it. To scale our...
Yeah, that's what, because you can't just do a chip, right? You already need a problem.
Increased numbers of threads. We need to have a much faster cycle time. So let me introduce our next generation robot.
So you do know the problem. The thing basically putting a web into your brain. It's easier to just do something outside the probably.
Through rethinking the way that we hold the implant in front of the robot by holding it directly in front on the robot head, we're able to achieve an 11 times cycle time improvement. So each thread takes 1.5 seconds. We also scale up a lot of surgery workflow process improvements through deleting the separate operator station and implant stand. Now, the outside of the robot looks pretty similar between the two, but it's what's inside that really counts.
Gamma waves,
Each
beta
system has
waves.
been redesigned from the ground up with the focus on reliability, manufacturability, serviceability, and using a lot
Cycle
of
per
our
second,
vertical
alpha
integration
waves,
techniques.
increment
It's
rates.
enabled us to have a lot more control of the system end to end. Now that fast cycle time doesn't mean much if it's not compatible
1
with a
hertz, 1
significant
cycles per
portion of the human
second. It's
population.
100 cycles per
Prior to each
second.
surgery, we scan participants' anatomy and ensure that they will be compatible with the robot and vice versa. Unfortunately, the robot isn't compatible with everyone, so we had to extend the reach of the needle in the next generation robot, and now we're compatible with more than 99% of the human population. We've also increased the depth that the needle can insert threads. Now it can reach more than 50 millimeters from the surface of the brain, accessing and enabling new indications. We have to produce a ton of custom sterile components for each surgery. We actually supply more than 20 of these parts. Many of these parts are made through traditional CNC manufacturing capabilities, which we do just on the other side of this wall, actually. and some custom developed processes like this femtosecond laser milling used to manufacture the tip of the needle. Now, these processes take quite a bit of time, effort, and cost. So let's take a look at how we're going to reduce costs and time for one of the components. So the current needle cartridge has a total cycle time of about 24 hours, and the machine components cost about $350. The final assembly is performed by a set of highly skilled technicians. They have to glue a 150 micron diameter cannula onto this wire EDM machined stainless steel base plate. They have to electropolish a 40 micron wire into a sharp taper, and then they have to thread that 40 micron wire into a 60 micron hole in the cannula. This is done manually.
40 micron.
And then they finally have to laser weld all the components together.
How wide is a brain cell?
Next generation needle cartridge takes only 30 minutes of cycle time.
4 microns.
$15 in component.
To
We were able
100
to
micron.
delete the wire EDM machined base plate and
About the same size as
by switching to an insert molded component. So we get a box of these base plates with the cameras already installed for 1,000 of them for a couple $5-10 a piece. We also deleted the electropolishing step with the revised needle tip geometry,
14 microns.
which is also compatible with inserting the threads through the dura. We have a few revised manufacturing techniques to delete the manual threading through
Here's the problem.
basically a funnel.
The
Rather
gap
subtle,
between
but it
neurons
has been
and
a big
synapse
impact.
is only about
And then we're able to delete the laser
nanometers. Wow.
Hi. Hi, I'm Julian. I'm one of the leads on the implant team. So, the way humans communicate today, if they want to output information, is by using their hands and their voice, as I'm doing right now.
Neurotransmitters for us.
And if you want to receive information, you use your ears and your eyes. And of course, that's how you're receiving this very talk. But we've built this implant.
No,
And
you don't have to
this
use your eyes.
implant is very
Apparently,
special
all
because
human
it
beings
is the
have.
first time that we're able to add a completely new mode of data transfer into and out of the brain. If you look at this device in a nutshell, it's really just sampling voltages in the brain and sending them over radio.
Yeah, I mean, basically, all human beings have the ability to receive my telepathy.
What you
What
actually
the hell?
see is that we're connecting your brain or a biological neural net to a machine learning model or a silicon neural net.
How
on
did
the
that work?
right-hand side. And I actually think
I mean,
this is really
apparently,
elegant
my brain,
because
Andrew's
the
brains are
machine
so
learning
powerful,
model
and
on
it's
the
actually
right-hand side
generated
is
brain
in
waves
fact
onto other human
inspired
beings.
by
I mean,
neurons
everybody's
on the left-hand
how
side.
the fuck
And so
did
in
that
some
shit work?
sense, we're really extending the fundamental substrate of the brain. For the first time, we're able to do this in a mass market product. That's a very, very
Scientifically,
special
this is actually getting some real, because it means every single human being theoretically has the same ability to receive brainwave, actual brainwaves.
So these
from,
are some of the first implants
how does that
we
work?
ever built. There are electrodes that were made with our in-house lithography tools. We have custom ASICs that we also designed in-house. And this was really a platform for us to develop the technology that allows us to sense micro-level volts.
Anyway, I was
in
gonna
the
say,
brain across
I
thousands of
mean,
channels
you only have
simultaneously.
about 4 minutes.
We
left,
learned a
so,
lot from this, but as you'll notice in the right two images, there are USB-C connectors.
About
on
Charlie,
these
you know,
devices.
and then
These are
scares
not
the shit
really
out of me,
used
you know, because I
implantable
thought I would be able to
implants.
protect you, and how?
This next
Right.
set of images are
If causality
wireless
isn't
implants.
produced,
And there was a complete evolution that we went through to add the battery, the antenna, the radio, and to make it actually fully implantable. Once it's implanted,
get
it's
it?
completely invisible. It's very compact, it's modular, and it's a general platform that you can use in many places in the brain.
It's finished, right? Mellow talk with
Going
President
from
Trump.
that top row to the bottom row is very challenging. The implant you see on the bottom right here is in fact the device that we have working in 7 participants today, and it's
Okay, so
augmenting
what do you-
their brain every day and restoring their autonomy. But getting to that point involved a huge number of formidable engineering challenges. We first had to make a hermetic
This is,
enclosure
talking to
passing
President,
1,000
yeah.
separate conductors through the
This
enclosure
is,
of the device. We had to figure out how to make charging seamless and work with very tight thermal
33
constraints in a
minutes.
very, very small area.
Okay.
And then we also had to scale
having
testing
mellow talk with the
infrastructure
president
so that we
yesterday
could
about
support large-scale manufacturing
about
and
Charlie,
very safe
you know,
devices and have
'cause,
confidence in our iteration cycle.
He's going to the funeral, so.
So what's next? We're going to be increasing our manufacturing so that we don't just produce, you know, a small number of implants per year, but thousands and then eventually millions of implants per year. We're also going to be increasing channel count.
President Trump.
More channels means more neurons are
Charlie.
sensed, which means more capabilities. In some sense, we often think a lot about the Moore's law.
I
of
could not
neurons
control
that we're
time
interacting with.
properly to
And
save
in the
his
same
life.
way that
Elon and,
Moore's law propelled forward many subsequent revolutions in computing, we think that sensing more and more neurons will also completely redefine how we interact with computers and reality at large. I want to leave you with one final thought. When I
I'm
was a
talking to Elon
child,
about how that
I
scares
used
me because
a
you know
56
I just
kilobit
always
modem
assumed
to
I would be
access
able
the
to
internet.
protect you, Elon, even without, you know.
If you remember what it's like, you go to a website.
I just thought I would probably just tell you something. Apparently, I might not be able to protect you, which just scares the shit out of me. You need that bodyguard, real actual bodyguard, Elon. Because, shit.
Incredible device, honestly. But then if you
Yeah, actual counter snipers, Elon. You need counter snipers. Because Charlie, he was killed by a sniper, so you need counter snipers. I cannot just protect him by magic.
Scroll like slowly, it was loading pixel by pixel on the screen. So that's what it's like to be bandwidth limited. Now imagine using the current internet with that same modem.
Anyway,
It's inconceivable. It would be impossible to do.
Jesus.
So what broadband internet did to the 56 kilobit modem is what this hardware is going to do to the brain. We are trying to drastically expand.
No, let's get solved the immune problem. Just physically not be able to solve. That's not what the human brain was.
Capabilities.
So at least we proved that we are not in the Matrix, which is scarier than being in the Matrix. I mean,
so I guess
the human race is not in the Matrix.
And to recap, today Neuralink is working reliably and has already changed the lives of 7 participants and making a real impact. And our next milestone is to go to market and enable scaling of this technology to thousands of people, and as well as expand functionalities beyond just the movement to enable sophisticated robotic arm control, speech, vision, give sight back, and even getting to the speed of thought. I hope you got a good sort of sample of our technology stack and the challenges that we have, and I'd like to hand over the mic to Elon for any closing remarks.
Jesus Christ. I mean, I'm starting to realize the COVID is not a fun virus, what the astrocytes actually do.
There's a lot of really smart people working on a lot of important problems.
How much gliosaurus does all of us have in our brain? Because astrocytes get infected, they're responsible for the scarring in their brain that creates damage. It's like giving everybody on the planet Alzheimer's, pre-Alzheimer's basically, and
super hard problem.
And we don't see any damage right now, but that scarring is probably permanent scarring. So we might have an issue in a few decades. We'll see. The human race might have some issues in the future. Yeah, that's problematic. Not a fun virus. Not a fun virus.